You know what is it called? Like the opposite of the
conjugate.
The conjugate, the opposite conjugate. Or
the conjugate, yeah.
When would I use that? Just whenever
two terms.
Whenever I have a two-term fraction
on the bottom.
Two terms.
So if you have just divided by square root of 3, you don't need a conjugate. But if you had square root of 3 minus 1, oh shit, you need square root of 3 plus 1. It's got two terms.
Okay.
Yeah. Let's see. Oh yeah. You'll have yours.
And the bottoms just cancel out.
No, they don't necessarily. You have to work it out and see what they become.
Okay.
Yeah. I don't know why I think I'm going to remember. Alright guys, let's take a look at these. So I think everybody's got the idea, the basic idea with this kind of problem. You get the radical by itself. A lot of us are making the most common mistake, which is when you square both sides, you're getting x squared plus 4, stuff like that. But, you know, I really want this to make... I know I say that a lot. Squares are based on multiplication. So if this was 2x squared, that's easy. I could just square each piece because exponents are based on what's happening inside. So it should be easy. Are the exponents based on what's happening inside here?
No.
Shit, it's going to take a little more work. I can't just do this because they don't play well together. Right? Because if I do write this twice, it's all multiplication, so I don't have any foiling to do or anything. But if I write this twice, oh shit. So when I do this, it's actually a shortcut. And then we try to apply the shortcut at the wrong time. I really want to hammer that in your heads. Immediately write that thing twice. This side. Be real careful, don't write him twice. Is the square still there?
No.
It's dead. Cool, I like it. These two kill each other. And then this side I get what do I get?
Minus 4x.
And then I move that stuff over, right? What's telling me what to do now? What tells me what to do? What part of this problem? The squared tells me I got to get it equal to 0. Right? Math really sucks, so it's nice. I don't believe that, but I'm just echoing what's in some of your heads. It's nice when math tells me what I'm supposed to do next. Right, so let that happen. Let it tell you. Poor little math, trying to help you. So how do I factor this? I like it. So you get two possible answers. Write both of them. Don't not write one, because then I'm worried that you missed it or you don't know that it exists. So these are two possible answers, but do they both work? No. Which one doesn't work?
1.
When you try to plug 1, you get square root of 1 is 1 plus 3 is 4, 1 plus 1 is 2. Well, that's shit. When you plug in 16, you get 18 minus 2 is 16, square root is 4, plus 3 is 7, 6 plus 1 is 7, 6 works, yeah. So you just got to take a second and check. I don't even need to see your check work. I just need to see the answers, the possible answers. Cross out any that don't work. Circle the ones that do work. Beautiful. I like it. So any questions on that? That's your classic radical equation. Okay, cool. This one's actually even easier because there's no outside x's. Do you see what I mean? So isolate your radical. Square it. And minus 2, minus 2. So I think somebody thought they were square rooting it, and I can't remember. They told somebody wrong because they were square rooting. I can't remember. But it's only when you square root that you have to put a plus or minus, not when you square. All right, if you check this, does it work? 1/5 of 5 is 1, 2 minus 1 is 1, square root of 1 is 1, plus 4 is 5. Sweet. So it works. This one is the demon. But it's important, if you internalize this fact, the square root of n times the square root of n is n. So the square root of x minus 1 times the square root of x minus 1 is x minus 1. Good. The second thing is, what's the basic rule of equations? If I do something to one side, I have to do the same thing to the other side. So if I wanted to square, I can't put a square there and there. I know I want to, but oh well, there's a lot of shit I want to do I can't do. I'd have to do this, and I go, well, actually, I really don't want to do that. Right? But I would have to if I wanted to do it right now. So it's gross because there's so many radicals. So the most I could do is get the radicals apart from each other. So it's not quite as disgusting. I had some trouble here, but just read this off to yourself. 2 plus, okay, that's how you write it. Don't make it times here. I know it makes the problem easier, but it also makes the answer wrong. Now you square both sides, and instead of putting a 2 here, I would even just write this twice, because that's what the square is going to mean, right? So you don't forget to FOIL that bad boy out. So I'll do this side. 3x plus 1. Plus 2 of these, plus another 2 of these, plus x minus 1. Yeah, we already did up there. Like it. And now it's cleanup time, right? Normally after you FOIL, it's cleanup time. Just get all your stuff together that you can, and then we'll have to worry about what to do next. So 4 minus 1 is 3, plus 4 of these things, plus x. So now forget where you came from. You're here. This is where you are. Doesn't matter that it came from a lot of other work. What's in there that tells me what to do? There's this radical, and I want to get the radical by itself. I love it. Yeah, you want to get it gone, right? You got to isolate it first, because then you can throw bombs at it, or whatever, how you want to look at it. Have Jon Snow go running at it. Sorry, is it too soon? It's a little brother. Oh, dead. So then we get 2x minus 2. Now. You do not have to divide by 4. You don't have to divide by anything. You got the radical basically by itself. If you square it now, you would just get 16 times x minus 1. But you could divide by 2. 2 goes into everything. It doesn't introduce fractions. It makes my number smaller. I like both of those things. I don't want fractions, and I want smaller numbers. So I can divide everything by 2. Real quick. Yes, sir.
How come you wouldn't divide the x minus 1 by 2 also?
I did.
Oh, you did? Because it's...
Somebody got this here?
Yeah.
So now watch this. There are 2 things I want to say. I like your question. What's 2x divided by 2?
X. 1.
Is there a 2 still alive to go into the x? No. So same thing happens here. 2 goes into 4 twice. That 2 is dead. Is there a 2 to go into this, or I couldn't even do it anyway, right? Do you guys see what I'm saying? When it's multiplication, division kills part of it. That's what division's job is. That's why that part was easy. But I'm curious if anybody's... I told you you can't do this, right? You can't put a square on each of those. Remember that? Okay. But so, I don't know if anybody then has a problem with what I did right here. I put a 2 underneath both of those. Didn't I? And we've done that before, right? But it's because division is based off of multiplication. Is that cool to say that? In fact, division is multiplication. Division by 2 is multiplication by 1/2. Is that cool? You guys with me? Yes. Exponents are based on multiplication. That's why they don't work well with subtraction and addition. Multiplication is based on addition. Do you guys understand that part? 4 times 3 is 12 because 4 3's add to be 12. Remember that from way back? You guys still with me a little bit? So, when a divide across subtraction, they work well together. It's easy. Because division is based on addition and subtraction. That's what it's based on. That's why it works easy. Alright, I might have said too much there, but... Because, I think some of you guys see me doing this, so your brain says, well, I should be able to do that then. Shit, Jeff. But it's because exponents don't play well with subtraction. Dividing does play well. Believe it or not. It is based on subtraction in a way. Alright, maybe. That's enough. Let's start over here. So you had x minus 1 equals 2. Rad x minus 1. Now what do I do to both sides? What did I do? Did I get there? Yes. Alright. So square both sides. So on this side I get x squared minus 2x plus 1. If you write that twice, right? Equals 4 times x minus 1. Square the 2. 4. Square the square root of x minus 1. X minus 1. Okay. And then this becomes 4x minus 4. And of course, what parts of this tells me what to do? The square. So I get x squared minus 6x plus 5 equals 0. And that factors to be... I like it. Whew. So your two answers are, two possible answers are, and do they both work? So if I plug a 1 in, I get square root of 4 is 2, square root of 0 is 0, that does equal 2. If I plug in a 5, I get square root of 16 is 4, 5 minus 1 is 4, square root of 4 is 2, 4 minus 2 is 2, check. So they do both work. Cool. So I really, again, it's all about why did I do what I did. I squared to kill the square root, and then I've got to just deal with that. By deciding to square, that means somewhere I'm going to have to work with that for a while. I got to clean it up. When I square that side, it gets gross. Let me clean it up, clean it up, clean it up, clean it up. Now I can square to kill the other radical. So there's a bunch of do something to get closer to your goal and then deal with what happened based on what you just did. I don't know how to say that better. All right. All right. So anything on that problem?
Okay, so over there, where you're at the 3x plus 1 is equal to 3 plus all that. So we subtract the x.
Subtract the x.
And then that leaves us with the 2x.
Subtract the 3.
So we're doing all that at the same time?
Oh, yeah, sure.
Okay.
Yeah. Well, you don't have to, but
Okay.
I don't like to write too much
Okay.
because I can't. All right. So, oh, what's up? Let me take this away. So 6D. Now watch. Some of you guys know now what to do. A lot of you guys went down a long path. But If I had this, what would you do first?
Square.
Try again.
-4.
See, you're answering too quick. You isolate where your variable is, right? Where's your variable stuck in the radical, so you isolate that piece. Where's my variable stuck? In the square, so I isolate that piece. Don't go foiling this thing out. That's crazy. See here, I isolated the radical, killed it. Here I can isolate the square, kill it. Sorry. Too much enjoyment now. Somebody should say, for loving math so much, you like to kill it all. That's because it comes back. So here, like I just said, what can I do to both sides? Square root.
Plus or minus.
Thank you. So then here you get minus 5x equals plus or minus 1. So when you apply the square root, you got to go plus or minus to capture both options. There are 2 square roots. Now, the correct way to proceed is to break this up. Because what could 2 minus 5x equal? It could equal 1, or it could equal negative 1. Right? That's what it says. 2 minus 5x equals plus or minus 1. So it could equal 1 or negative 1. Now you can solve each of those. Get your 2 answers. Why does it make sense that there's 2 answers? Squared, right? It's a squared thing. Should be 2 answers. So I get x equals 1/5, or x equals 3/5. It's not so imperative to check this one because I can plug anything into a square. And the answer, I don't know if you guys see what I'm saying. The square root problems, you have to check them because some of them might work. Here, if I check them, I'm just making sure I did it right. If I did everything right, I'm guaranteed my answers will work. It's not going to make anything undefined because it's squares. They don't have problems. Square roots have problems. All right. Maybe. And then E. We've done this kind of problem a lot, right? So y over 1 minus 2 over 3y equals... I just threw this in there, I guess, to see if you remember. So, I mean, there's several different ways to do it, but the way I showed you is to make everybody have equal same denominator. I like it. So, what's he need? He needs a y. He needs 3. And he needs everything. Okay, I can kill these. Bam, dead. So you have 9y squared minus 6. Yeah, equals 25y. Yeah, move the 25y. 9y squared minus 25y minus 6 equals 0. Now, some of you guys might have gone ahead and did quadratic formula. Possibly. I would say, hopefully you don't. You always try factoring first because it's the quickest way. This will factor. All right, 9 times negative 6, negative 54. 27 and 2, I like it. Which one's negative?
27.
Good. So now I can write this as 9y squared minus 27y plus 2y minus 6 equals 0. And then group, I like it. 9y. So you get 9y plus 2y minus 3 equals 0. So you get y equals negative 2/9 or y equals 3. And of course, the only number that I have to watch out for is y equal to 0. I didn't get that. Good. All right, so part F is a bigger idea because I told you a while back. We used to say x cubed equals 27. The answer is 3 because you cube root both sides. But we know x cubed has to have how many answers?
3.
It must have 3 of them. So we were just missing the complex answers because, of course, back then Oh, remember us back then? We didn't know anything. Now we know complex numbers exist. They're real. They complete that whole idea. So the correct, all right, Jeff. Elmer Fudd teaches math. The correct way to do this, children, is to, I'm glad somebody else appreciated that. The correct way to do that is to move that over. I mean, see the higher power of the x? So officially we should always be making it equal to 0. Because then I can do what with this? Yeah. X minus 2. Good, plus 2x. Plus 4. There's my real answer. And from here I'm going to get my complex answers. Right? Because again, if I check b squared minus 4ac, I get 4 minus 4 times 1 times 4. I get 4 minus 16. I get negative 12. I know it's going to be complex answers. And like I said earlier, it's nice to do that on the side because now I can say x equals negative b plus or minus square root of that. I've already done all the work there. All over 2. Now this you can at least take care of this, but then the 12 can also be, so it'll be I, 12 is 4 times 3, negative 2 plus or minus 2i, rad 3 over 2, and then I just divide everything by 2. It's funny, as I'm saying that, it's like me watching Bob Ross back when he was around. And he's like, and then you just do this, and there's a tree. I'm like, no, Bob. No, it's not a tree. I'm not sure what I'm making. It's not what you are. So I'm sure some of you guys feel the same. And then you just do this, and then there's the answer. It's amazing. Yes?
Why can't you cube the 8? Like, when you get the 8 on the other side, why can't you put a cube? Like, you know how
You totally can. But did you give me all the answers? If you do that, you only get the real answer. So, to be honest, I really want you to understand this. It's a little tiny bit beyond this, but I'm going to relate it on one level at least. Square root of 9 is the positive root. There are 2 roots to everything. So we have a quick way to take care of that. We just put plus or minus. Cube roots, when I cube root something, that's the real root. That's the positive root. There's a negative root of 9, negative 3, right? For cube roots, it's worse. If I do this, I only get the real root. So if I say this, there are 3 answers to this. By cube rooting, you're only getting 1 answer. This is the only process we have to get the other 2 answers. This, I can just put plus or minus. So yeah, if I had x squared minus 16 equals 0, screw factoring. Let me just do this. Plus or minus 4, I'm done. Yay! This is an easy way to take care of the 2 answers. Cube roots, there's no easy way to take care of the 3 because 2 of them are freaking ugly. This is the only way we have to do it. Yeah, and the higher the powers get, the worse it gets. So for example, did I finish everything? Yes. Look at this problem here. X to the 4th equals 81. How many answers must there be? 4. So if I take a 4th root of both sides, it seems like I'm only going to get 1 answer. But I have to put plus or minus for the fact that it's an even root. But that's still only 2 answers. Right? So what's the correct way to do this based on what we just did? Yeah, subtract 81. How do you factor this? Which one can you factor further?
And negative minus.
So you get x equals negative 3, x equals 3, or x squared plus 9 equals 0. We can factor. I'll show you in a minute, but we can solve that, right? Subtract 9, take a square root, and I put plus or minus, so I get x equals plus or minus 3i. So there are the other 2 hidden answers, right? So I don't know if some of you guys are picking up on what just happened. Are picking up on what I'm laying down. The x squared minus 9 is x plus 3x minus 3. X squared plus 9 is x plus 3i, x minus 3i. Kabam. Because what's the weird shit that I does? What's I squared? Oh shit, so I times I, if I square I don't get a positive. I get a negative. So it's able to handle what real numbers can't. So why can't I factor this with real numbers? Because there's no real number that will, how do I say this? There's no real number that will cancel out with itself unless they have opposite signs, and they'll multiply to be a negative then, right? But here, what's negative I times I? Negative I squared, which is negative 1, which is positive 1. I don't know if you guys... So now I can do sum of squares. I just have to use complex numbers to do it. So if I saw x squared plus 25, how do you factor that?
X plus 5i.
I, yeah, good. X minus 5i. Because what do you get? You get x squared plus 5ix minus 5ix minus 25i squared. I squared is, so that makes it plus 25. See, that's what saves the ass of it. The fact that it's got complex numbers at the end makes it become a plus at the end. I think I just blew some of your minds, but it's not that big of a deal. That's an immediate implication of the fact that I have a number squared is negative. I should be able to go back and do more than I could have before with real numbers. And that's one example of that. All right. Now there are a couple other things I left off the answer key. The end of number 11.
Oh, yeah.
I think it was the 11C, and then number 12. I don't know why I put number 12 when I already have number 5 on there, but oh well. I do have 11B on there, yeah. Okay. Okay. So for example, if I saw this, oh, what you got, Jeff? Well, I think this is the one before that, right? Or is it 8B or something? Well, let's make a new problem. What's the idea here? I mean, how many more B's do I need down here? 3 more B's. So when the bottom is a single term, I don't need conjugate. The only reason the conjugate exists is when I have more shit to take care of. It's going to be more complicated. Here I can just attack this directly. You need 3 more B's, 1 more 2, and then you'll have 4 of everything. So you can actually do the 4th root, right? So you multiply this by 1 more 2 and 3 more B's. So the bottom would become 2B. Right? You guys see that? So it'd be 4th root of 16B, the 4th on the bottom, right?
Yeah.
What's the 4th root of 16? 2. 4th root of B4? And the top would just be whatever the hell when you multiply, you just slam those together. Right? So the top is just sitting there getting hit by whatever the hell the bottom needs. Maybe. So what's my point? Single term on the bottom, easier. You just give it what the root needs. More than one term on the bottom, oh shit. I can't just multiply by rad 5, because then that would become rad 5. I still have a radical down there. So I have to multiply by plus 1, yes. Is that cool? So that's where the conjugate comes in. The conjugate also comes in when I have like 3 plus I on the bottom, because I is just the square root of -1. So it's got to work the same way. So on the top, I'm going to get
Square root of 10.
square root of 10, square root of 2. Is this square root of 15?
No.
Good. All over
5.
5. Minus plus, so those go away. -1, so I get blah, blah, blah over 4. Don't make me write it again.
I like that.
4. Okay, cool. I like it. Because the top, you can't do anything with any of these, so you don't. Don't feel like you have to be able to. You can't. No like terms up here, right? Don't make that square root of 12. A little t here comes out. Okay. Sorry. Okay. On number 12, I mean, which one of those is all real numbers on number 12? One of them is. 12 asks you for the domain. Part B is all real numbers because it's a cube root. And 12a, it's the square roots is going to have some trouble, right? I also ask you to graph it, so let's do that for part A here. How do I find this guy's domain? And the domain is going to help me graph it because it's going to help me start at the right place in my table, my XY table. How do I find the domain? Not equal to 0.
Greater or less than?
Well, that would be everything except 0. The inside's got to be 0 or positive, so it's got to be 0 or bigger than 0. Always, for a square root, for any even root. How we doing? So the reason this is, I know we just learned about complex numbers, but when I say find the domain, that's implied to mean real numbers. If I wanted complex numbers also, I'd have to say find the domain over the complex numbers. I have to be very